Good afternoon, morning, or evening, students. Math Foundations 30 today, and this is our fourth day in the curve sketching unit, our best fit curve unit, and we're actually going to do curves now. We're going to do quadratic and cubic regression. Sounds really complex. It isn't, not with Desmos. We're going to do it with Desmos. So you might want to have Chromebook handy before you start this. You might be watching on a Chromebook. So you might need an extra one just to be able to do it on the side, or you might flip back and forth between the video and your Chromebook, whatever way you decide, doesn't matter to me. Okay, I'm going to have to do some notes and as well. So what we're going to do today, we did linear regression yesterday. We're going to do quadratic regression. I'm going to do the demonstrations today. And then next day, I'm going to give you some, I'm going to take a couple of from 6.3 and a couple from 6.4 and let you work on those out of the textbook using Desmos. Okay, we haven't done any hand-drawn ones yet, but we will do that. So this will do linear regression, or this will do quadratic regression and cubic regression today, examples. And then tomorrow we'll just do some practice. You may have tried some linear regression ones already, so you might be ahead on that. That's fine, okay, using those. Okay, so what are we going to do today? Okay, so what we're going to do is we're going to set up this first, I guess. Okay, so this is day 4 of the curves unit, polynomial and sinusoidal curves. Okay, sinusoidal, I spelled wrong. I in there we go. Okay, this is basically unit 4. What we're going to do is we're going to use, today we're going to use Desmos to find lines or curves of quadratic and linear regression. Okay, so that's what we're going to do today, or this morning. So all I'm going to do there is I'm going to do 2 to 3 examples, depending on how much time we have. Probably at least 2, one of each kind. And then next day on day 5, I'll leave you with some practice. You can whip out your Chromebook or a computer and just work on Desmos to do that. So let's start off with an example here of doing some data. I'm just going to steal one from the end of the unit here. I don't know if this is square, if this is which kind of regression this is, which is good. I don't know. Then we'll figure it out. So let's start off with example 1. So let's say we have some data. A spherical balloon is being inflated. The surface area changes. In A square meters. We should put A in brackets. That stands for area. As a function of time in minutes. Okay, so we got this table here. Okay, I'm going to do it in marker so that I can don't do it quickly. So the surface area and the time. So 0 seconds, 13, and 1 is 28. 2, 3, and 4. So 28, 50, 79, and 1, 13. So there's our data. So it's real simple data. Okay, and the questions are: create a scatter plot. Okay, we're going to use Desmos for that. And it says determine the quadratic. So it's a quadratic regression function. There we go. Desmos will do that for us or help us with that anyway. Okay. The last one is use your function to, use the function to, do you want to extrapolate or interpolate? Interpolate, let's say, 70 square meters of surface area time at 70 square meters. And we'll do an extrapolate. Use the function to extrapolate up 6 minutes. Okay, so that'll be our question. So we're going to do this on Desmos. So let's bring over Desmos. Okay, everybody's got that, hopefully. And I'm going to put this on my other screen so I can see it as I'm doing it. Okay, so there's our table of data. It's only 5 points, so it shouldn't take us too long. Okay, so the first thing I'm going to do is bring over Desmos here. Snap it in the window. Okay, the first thing I want to do is I want to set up my axes. So it's going up to 113 on the surface area, and we're going to be extrapolating. So maybe we'll go to 150 or something like that. And the time we're going to extrapolate is up to 6 minutes. So maybe we'll go from 0 to 7. So let's go ahead and hit the wrench. Change our x-axis from 0. That's where we're going to put the minutes, is on the x-axis. And we're going to go, we could go up to 10 if we wanted, but let's go up to 8 or so. And then the surface area, we're going to start at 0 because there's no negative error. And I don't know what we're going to need for it, but let's start with 150. We might need more. We might have to change that later. Okay. Click those down, and that gives us our graphic window or to look at it. Create a scatter plot. Okay, so over here in where the plus sign is, we click it and get our table. Okay, and we put our X points in 0, 1, not 0, 0, 1, 2, 3, and 4 minutes. Okay, and then at 0 we had 13 square meters. Okay, you can see the point right there. Okay, and then we had 28. Then we had 50. And we can do a lot more questions using Desmos, eh? Doesn't take as long to graph. If we're doing this by hand, it would take us longer, right? Okay, 113 there. So there's our data points. Okay, 1, 2, 3, 4, 5. So is that a straight line? We don't know. Well, it says in the question it says use the quadratic regression function. But if we weren't sure on that, we would have to check and see if it was a line. Let's check and see. If we thought it was a line, we'd go y1 is approximately equal. Remember, I screwed that up last time. Oops, not that one. That one. Approximately equal to mx1 plus b. Okay, and you can see that, well, that's not bad, right? Let's just leave that one out there. But it says make the quadratic regression function. So that's the line one. If we do the quadratic regression function, remember that is y1 is approximately equal. Now, you have to use quadratic, so that's x squared term. So you go a x1 squared. Okay, now how do you get the square in there? Well, on the keyboard, you can use this, you can bring the keyboard up here on the bottom. And that's not the keyboard there. It's over here. But this is my Desmos getting in the way. Anyways, you can bring up the keyboard if I didn't have these Desmos controls here. Or, sorry, these screencastify controls. It's down here. Or you could just use the caret 6 on your keyboard. So you would go shift above the 6. Okay, and that gives you the ability to square it. Okay, and then it's not that, doesn't look that close, right? Well, let's put in plus bx1 plus c. Okay, and which one looks better, the black or the purple line? Well, in my eyes, which are old, or than yours probably, it looks like this is a quadratic function, right? Because it fits that curve there, and it gives us what the value of a, b, and c are. So when it asks us the second question, determine the quadratic regression function that models the data, we can see it right here. It tells us what a is, what b is, and what c is. So that c represents the constant term, b represents a term in front of the x, and a represents a term in front of the x squared. Okay, so we can actually write the regression function out. So let's go ahead and do that on our page here. So I'm going to switch these around so you can see me writing it down, but you can see it on your screen. But we should be clear to answer this. So let's go ahead and open this up with answering it. So we created the scatter plot on the screen there. Okay, we'll get to black here again. Okay, so this is done. Okay, we determined the quadratic regression function. So B is, okay, so I'm going to just write it out. So according to what it says on the screen, and I have to stare at it a little bit, it says that the quadratic function is y equals, okay, ax squared. So a is 3.21429. 3.21, and how far should I go? I don't know. 429. I'm just going to write the whole thing in. X squared. Okay, and then it says B is 12.2429 plus 12.2429x. Okay, and then it says, I got to take my glasses off, I got bad eyes. 12.8286. Okay, and they're all positives. 8286. So this is our linear, or sorry, not linear, our quadratic regression function. So where did I get that? I read the values off the black line. Now we tried the linear function. We could eliminate the linear function. We don't need this one here because it's not a linear function. So we can get rid of that. There it is. So I got those values from there, there, and there. Remembering to use this approximate and these one subscripts for x's. Okay, and that's how Desmos is able to do it. So that's our linear regression function. Now it says use the function to interpolate the time at 70 square meters. Okay, so this one here, we have x as a function. I guess I shouldn't have put x, I should have put t's in there, right? Because we actually put the variable t up here. My mistake. And this should have been y, but we can leave it like that. So if y was 70, what would x be? Well, that's kind of hard to do with the function unless you know factoring. Okay, so it's probably easier there's a couple ways. I don't know if you guys know the quadratic formula or not, but if you don't know the quadratic formula, you have to kind of go on here and go, well, where would 70 be? Okay, so if we click on here and we want 70, well, there's 80 and there's 100. So if we go in here and bring it up to where I can get a 70, well, what am I doing? That's 80 and 100. 60 and 80. There, we got to go in here, right? So up to 70. So as I go up to 60, okay, it looks like it's about 2.72. Okay, so that would tell us about 2.72 minutes. Okay, well, we don't obviously do minutes in decimals, but we could change that 0.72 to seconds if we wanted to. So we can say that for C, okay, in C, 2.72 minutes. Okay, now if we wanted to, we know that there's 60 seconds in a minute, so we could change 0.72 by multiplying it by 60 into seconds. 0.72 times 60, whoops, 0.72 times 60 is about 43. So it's 2 minutes, 43 seconds. Or this is good too. I'm not going to say that's wrong because it's not. This is just more traditional. Okay, and the last question is use the function to extrapolate 6 minutes. So we can do that on the function there. Now, 6 minutes is easy to extrapolate. It represents the time, so it represents our x in this case. So we can do it one of two ways. We can go y equals 3.21429 times 6 squared plus 12.2429 times 6 plus this and get an answer. Oh, was it 8686? It was 8286. Sorry, guys. Okay, so we could do it that way. Okay, do a little calculator exercise and get it, or we could just do it on the graph. And we'll do it both ways to see if they match up. So 3.21429 times 6 squared, which is 36, plus 12.2429 times 6 plus 12.8286. So I get, when I do that, 202 approximately. So it should be 202 meters squared. Okay, so let's check that on the graph and make sure that we're on the same page here. All right, so if I go on here, I want to go all the way up to 6 minutes, which would be all the way over here. It's not on the graph, so I have to bring my graph and pull it down so that I can get that high, because it's over 150, right? So I'm just going to pull it down. Okay, 6 minutes is right about here. It looks like it's about 200 and something. Okay, there's 6 minutes, 202.4. 6, get closer to 6. There's 5.994. So right in there, there we go, 6 and 202. Perfect. Looks like we know what we're doing. Okay, so that's our answer for the area. Okay, so I'm going to do one more example, and then tomorrow I'm going to pause it, and this time I will actually pause it, and find a cubic regression one for us to do. Okay, guys, here's the cubic regression one. I haven't put the table up yet, but I'm just stealing one out of the book here. Okay, it says a balloon inflates, so the volume V in cubic centimeters is a function of time t in seconds. Plot the graph. Use cubic regression to find the equation. What is the volume at 10.5 seconds? Okay, so here's my chart that we're going to use. So let's say I'm just say our time in seconds and our volume. So our time is 0, 1, 2, 3, 4 again. And this time we have 33.15 or 51. Then we have 113.10, 268.08. It's number 4 on page 420 if you're looking. 23.60, and our last one 904.78. Okay, so there's our graph that we're going to do cubic regression on. Okay, and like I said, I'm going to do the cubic regression example. We'll stop there today. It'll probably take us another 15 minutes or so. We'll stop. And then I will assign some questions to do from 6.3 and some questions to do from 6.4 next day, where you can use Desmos to do them and see what the formula is. And there's some bookwork there. You still need to use the formulas to predict some things, interpolate and extrapolate things. Okay, so that's kind of our plan for the next couple of days anyway. Okay, so let's pull this over and Desmos this up. Okay, so let's switch our spots here. Pull that over. Put Desmos over here. I got to redo my window. It's still from when we did the last one. And keep my table open there. Okay, so my window I'm going to have, it's going to go from 0 to, let's go from 0 to 5 on the x-axis. That's our time. Okay, volume is a function of time. So that means time goes on the x-axis and volume is the y. Okay, so we're going to go from 0 to 5 seconds. Okay, there we go. And this one we're going to go from 0 to 1,000. Let's go with 1,100. That should be good. Okay, so now we click on here and put our table in. So there we're going to have 0, 1, 2, 3, and 4 seconds. Okay, so add 0. Oops, I missed one here. We don't want that. Oops, I went too far. Oops. All right, so there we go. 0 goes there. All right, so let's put in 33.15 5.1, pardon me, cubic centimeters. 113.1 cubic centimeters. 2 is 268.08 cubic centimeters. 3 was 523.6, and then 904.78. Okay, a lot quicker than us trying to graph it by hand. Okay, there we have, could be a quadratic, could be a cubic, could be a linear. You don't know. So let's pretend you didn't know, just guess. So you could try a line. So you know that a line is y1 is approximately equal to mx1 plus b. Ooh, that doesn't look like a great one. We'll leave that one up there, the red, and we'll put in, well, maybe it's a quadratic. You know that a quadratic equation is y1 is approximately equal to, and then you just do the squared term first, just any variable, ax1, the caret sign above the 6 to go to squared, okay? But push the arrow key plus bx1 plus c. That's not bad at all. Could be a quadratic regression. If maybe it is. No, it says use cubic regression. Okay, so like that looks pretty close. Good, right? Okay, well, let's try cubic regression. Cubic regression is y1 is approximately equal to. So cubic regression is cubes. So ax1 caret above the 6, 3. Arrow to get that back there, plus bx1 caret above the 6 to get the square. Okay. And forward again, plus cx1 plus d. Okay, so there's a cubic regression. Well, it's actually a little closer than the purple one. Is it's hitting the lines. So let's take and erase the ones we don't need, like this one here, the red line is getting in our way. Get rid of it. Black line looks just slightly closer than the quadratic line. Okay, very close, but so let's erase the purple line. And there's our cubic regression. Oh yeah, that one works out beautiful. Okay, so we have now plotted it. So we did question part A. We now have the cubic regression line, and here are our variables A, B, C, and D. Don't worry about this stuff. That's just some statistical stuff. So now we have to just write this equation out by plugging in these values right here. Okay, so our equation of quadratic regression, and this time I'm not going to use y and x, I'm going to use v and t so that I do it a little bit properly. So I'm going to move this over, bring this back over, and we're going to answer that question. B, use cubic regression to find the linear, equation. So the equation as a function of vt, let's say. So let's say it would be then, for B, okay, v as a function of t instead of y, but you could put a y there, I wouldn't freak out, equals. Okay, now I'm going to use function of t. So instead of x, I'm going to use a t. So I'm going to put the a down first. A is 4.18917. 4.18917. T cubed plus b, which is 25.1307. T squared plus c, which is 50.2. Oh boy, my eyes are bad here. 50.2 0.65, I think. Okay, and X, or sorry, T. And the D value, the last number was 33.5104. Okay, so now it asks us, well, what if they want you to extrapolate at 10 seconds, 10 and a half seconds. So we can do that with our calculator now using this equation, or we could do it on the graph. Now the graph that we drew wasn't big enough to extrapolate it. So one of the things we could do is to do what it would be at 10.5 seconds. So 4.18917 times 10.5 cubed plus 2.25.1307 times 10.5 squared plus 50.265 times 10.5 plus 33.5104. Okay, so if I plug that into the calculator, let's move this up so we can see it better. We should get an answer for that, and that's where, and then we'll double check it on the graph. Okay, so 10.5 cubed, that's what I'm going to start with, times 4.18917 equals that, plus 25.1307 times 10.5 squared equals that, plus 50.2565 times 10.5 equals that, plus 33.5104. You could probably round those a little bit if you want to. So I'm going to go to the nearest one there. I got 8,181 cubic centimeters. Okay, so that's why I use the equation. So if we look at the graph, we have to really extrapolate it up the graph to find it. But we can do it with Desmos because we can move our window. So, okay, if we want 10.5, we're only up way over here. So we got to move this all the way to 10.5. See that? That's still 7. Oh, 10 is right there, and we don't see the line, so we got to go up. Don't see the line, got to go up, got to go up. So if we zoomed out, just help us out, got to keep going up yet. So 10.5. Now if we go in here, it should be in there. That's 10.5. 4. Keep going down a little bit more here. Okay, 10.5 is 8,181.469. Matches up with our graph as it should. And that is cubic regression. An example of that. Okay. So that's using Desmos. Now we haven't done any hand ones, but that's fine. So what we're going to do then is I'm going to give you some practice from both. And that'll be next day because we've used up about 35 minutes. But I'm going to, if you want to get started today, I'm going to give you what I will give you in both sections from 6.3 and 6.4, okay, for you to try. Okay, so you can try, and then I'll post them and you can work on them tomorrow, just using Desmos. So using Desmos, okay, 6.3, which is page 408 to 410. Okay, I'm going to give you, I'll give you 3 there. Try 7. These are linear. 7, I can't remember which ones I gave you. I think it was 8 and 10. Okay, and then on 6.4, okay, so if we were doing these by hand, that'd be a heck of a lot. But we're doing them by computer, Desmos. And this is on page 419 to 421. Okay, try number, I did 4 on there, but try 3 and 5. I did 4. 6 is good too. 7 and 8, and that should be lots. Okay, that's a lot of questions, but because you're using Desmos, it shouldn't take you too long. So that's what you can do next day. Okay, so the next day will be a work period on those 2 sections, using Desmos to do those graphs and answer those questions about regression lines. Okay, good luck. And I'm going to stop at this point at about whatever minutes we're at, about 37 or so. See you tomorrow, or I guess you'll be working tomorrow. See you the day after that.